Imagine you're riding on a high-speed train, just gazing out the window, and you glance down at your own shoes.
Right, just a totally normal thing to do.
Exactly. And it feels instantaneous, right? Like the shoes are just there. They're existing in the present moment with you. But here's a question that kind of completely breaks that intuitive sense of reality. Are you seeing your shoes now, or are you actually seeing a past version of your shoes?
Well, the physics of light leaves absolutely no room for debate on this. It demands a delay. I mean, even if it's just a tiny fraction of a nanosecond, light takes time to travel from your shoe to your retina.
Yeah.
So you are quite literally looking into the past. But we're conditioned to just, trust our immediate perception, to believe that what's in front of us simply is.
Which brings up this massive historical paradox we're getting into today. Because how did the smartest physicists in history, like the actual architects of relativity, build their grandest theories on a map of the universe that doesn't actually exist?
It's a huge question.
Right. So today we're doing a deep dive into a highly detailed critique of modern physics. We're pulling from a series of draft notes and articles with these really provocative titles, like Einstein's slack off or Einstein's oversight.
Yeah, they really don't hold back.
No, they don't. And the core argument here is that the foundational thought experiments we use to understand space and time, well, they rely on a fundamental, unacknowledged illusion.
And the author targets the absolute bedrock of relativity here. To really understand the flaw they're pointing out, we have to look at the prime example, which is Albert Einstein's famous light clock thought experiment.
Okay, let's re-examine that setup for everyone. So you have a clock that measures time by bouncing a single photon of light back and forth between two mirrors, right? Like a floor and a ceiling.
Exactly.
And you put this clock on a moving train. So for an observer standing still on the platform, the light has to travel in this diagonal zigzag path because, the clock is moving forward while the light bounces up and down.
Right. And since the speed of light is constant, that longer diagonal path means time must be ticking slower on the train. Time dilation.
Boom. Relativity. But the author of these drafts has a serious problem with this.
Well, mathematically, it is sound. The critique, however, points out this massive conceptual blind spot in how Einstein actually visualizes the stage for this experiment.
How so?
So Einstein places this moving clock inside a rigid three-dimensional Cartesian grid, a classic XYZ coordinate system.
Right.
And crucially, he imagines we can look at this grid at a specific instant, a frozen snapshot in time, say t equals 0. The author actually jokingly refers to this as having an out-of-body experience.
Okay, I see the problem.
Yeah.
Because it requires like a God's eye view. You have to imagine you're hovering somewhere completely outside the universe, magically able to see the floor of the clock and the ceiling of the clock at the exact same instant to even draw that diagonal line.
Exactly. And the author traces this assumption back to German idealism, actually.
Yeah, philosophy?
Yeah, it's a philosophical approach that treats mathematical perfection and conceptual spaces as more real than messy physical reality. If you approach physics through German idealism, you kind of treat space as a purely mathematical playground.
Where you can just declare by fiat that the entire grid exists simultaneously in your mind.
Right. But we aren't abstract concepts. We don't have a God's eye view. And the author places a massive emphasis on what they call physicality.
Physicality.
Yeah, they constantly reference an observer who is specifically, well, they say 1 meter and 67 centimeters tall.
I love that specific detail.
It grounds it, right.
Yeah.
You are not a floating coordinate point on an XY axis. You are flesh and blood. You have a physical retina, a camera eye.
Okay, but that camera eye completely shatters the God's eye view, doesn't it? Because it's subject to the strict speed limit of the universe.
Completely. In Einstein's conceptual space, you can say, oh, the ceiling of the clock is here and the floor is there right now. But in physical reality, the light bouncing off the ceiling of that clock is physically further away from your retina than the light bouncing off the floor.
Okay, wait, I have to push back here a little bit. Because didn't Einstein literally invent relativity by obsessing over the speed limit of light? Like, that was his whole thing.
Yeah, absolutely.
So how could he possibly forget that light takes time to travel from the ceiling to the floor? That seems like a crazy oversight.
Well, it's not that he forgot the speed of light. Einstein accounted for the speed of light mathematically in his equations.
Okay.
The issue is conceptually. In setting up the stage for his thought experiments, he treats the present space as a given. He imagines the train, the clock, the tracks, all existing perfectly synchronized in that frozen t equals 0 snapshot, just ready to be observed.
Oh, man, it sounds exactly like lag in an online multiplayer video game.
Oh, that's a great analogy. How so?
Well, the game server knows exactly where every player is at total zero, right?
Yeah.
The server has the God's eye view.
Right.
But on your screen, because of your ping, because of information delay, you're seeing players where they were a fraction of a second ago.
Yeah.
So the server's map is mathematically perfect, but your actual screen is a mess of delayed information.
That is perfectly put, yes. The author argues that because of this information delay, true simultaneity in physical observation is just physically impossible.
Because the light from the ceiling takes longer to reach your retina than the light from the floor.
Exactly. Therefore, the visual image of the clock constructed in your brain isn't a snapshot of a single moment. It's this composite of different moments in the past.
Okay, so if our entire visual field is just a messy, delayed patchwork of light, then Einstein's flat 3D grid is completely useless for a physical observer because we can't actually see the grid.
Right, we can't.
So how are we actually seeing moving objects in the real world? Like when I watch a train go by, it looks like a solid, cohesive object in the present.
Well, the illusion of a cohesive present is the result of what the author calls deflection shooting.
Deflection shooting?
Yeah, let's apply this to your train example. You're on a train, and another train is passing you, going the opposite direction at, let's say, 10% the speed of light.
Fast train.
Very fast. The light bouncing off that passing train doesn't just beam in a straight, simple line to your eye.
Because my eye is moving too. I'm moving forward through the electromagnetic field while the other train moves past me.
Exactly. The light from that passing train has to actively chase your moving retina.
Like a fighter pilot in a dogfight.
Yes.
If you want to shoot down a moving plane, you don't aim where the plane is right now. You aim where the plane will be by the time your bullets get there. You have to lead the target. That's a deflection shot.
Exactly.
So you're saying the light rays hitting my eye are literally executing successful deflection shots just to be seen by me.
It is a brutal physical reality. The visual image in your brain isn't just delayed. It is a stitched together patchwork of light rays that departed their targets at wildly different times in the past, traveled across space, executed perfect deflection shots, and finally caught up to your moving eyeball all at the exact same instant.
Wow. So the map really is not a territory.
No.
The rigid 3D grid of space is a fictional map, but the physical reality of deflection shooting light hitting a moving eyeball, that's the actual territory.
And the sources highlight a crazy example of this. The author talks about looking out the window of a moving train at the passing tracks.
Okay.
If you put your eye, say, 3 centimeters away from the glass versus stepping back and looking from 30 centimeters away, you actually change the pass degree of the light hitting your eye.
Wait, really just by moving my head back?
Yeah. Moving your head back means the light has to travel a slightly longer distance inside the train carriage to reach your retina.
Oh, I see.
And that physical distance requires more time, meaning the light had to depart the passing tracks just a tiny fraction of a moment earlier.
So by simply leaning back from the window, I'm looking slightly deeper into the past?
Yes.
And that tiny shift completely ruins the concept of universal simultaneity. Like, if moving my head back a few inches completely changes the timestamp of reality hitting my eye, we have a huge problem.
A massive problem.
How do we ever agree on where things are? If everything is a delayed deflection shot patchwork, we clearly need a completely new way to measure distance.
And that's exactly where the author goes next.
Yeah.
We have to abandon the Cartesian grid entirely. You cannot map a subjective, moving, delayed reality onto a flat XYZ plane.
So what's the alternative?
The author introduces a completely new geometric model to replace it. They call it the time sphere, or sometimes the celestial sphere screen.
Okay, let's really break down the mechanics of this, because a sphere made of time sounds like, I don't know, abstract nonsense if we don't ground it.
Fair enough.
How does this time sphere solve the physical retina problem?
Okay, so instead of imagining yourself as a point on a flat grid, you place your physical observer, your camera eye, at the dead center of a sphere.
Right in the middle.
Right. And in this model, distance is no longer measured by physical length, like meters or miles. Distance is strictly defined by time distance. Literally how far into the past the light originated.
Okay, so the surface of the sphere represents a specific moment in the past. If I look further out, I'm just looking at larger, older spheres.
Exactly. But here is the critical part, and this is really the main focus of the author's work here. How do you establish a universal rule for measurement inside a sphere where distance equals time?
Yeah, how do you do that?
The author brings in the centerpiece of their new model, the standard meter.
Wait, the standard meter, like the actual historical physical archetype of measurement. The literal platinum iridium bar kept in a vault in Paris that defined exactly what a meter was.
That's the one.
But how does putting a physical metal bar into a theoretical sphere of time fix the fact that my eyeball is moving?
Well, we aren't putting the physical bar in the sphere, per se. We are taking the concept of that standard unit of distance and projecting it geometrically.
Okay, explain that.
In classical physics, you'd lay a straight metal bar down on your 3D grid and just count how many bars fit between point A and point B.
Right, simple enough.
But in the time sphere, the straight physical length of the standard meter is projected as an arc on the surface of the sphere.
Wait, you curve it. You're bending the straight ruler along the bubble of time.
You have to curve it. Think about the geometry here. If you take a perfectly straight ruler and place it near a central observer, the two ends of the ruler are physically further away from the observer's eye than the exact middle of the ruler.
Right. If I hold a ruler right in front of my face, the center is closest to my nose, and the tips are angled further away.
Exactly. And because the ends are further away, the light from the ends takes longer to reach you. In a model where distance equals time, the ends of a straight ruler exist in a different time than the middle of the ruler. You never actually see the whole straight ruler at once in its present state.
Information delay strikes again. The straight line ruins simultaneity.
Yes. So by projecting the standard meter as an arc curved along the surface of the time sphere, you fix that exact problem.
Because the radius of a sphere is constant.
Right. Every single millimeter of that curved arc is now perfectly equidistant from the observer at the center.
Oh, wow. So if every point on the arc is the exact same distance from the center, and we establish that distance equals time, then every point on that standard meter exists at the exact same moment in the past.
You've got it. And to explain how this works mathematically, the author introduces a concept called pseudo-light rays.
What is a pseudo-light ray? Is that like a physical photon?
No, it's a mathematical tracer. Real light is chaotic,
Yeah.
right? It's bouncing everywhere, hitting your moving retina at wildly different times after executing all those deflection shots we talked about. A pseudo-light ray is a perfect, logical line drawn from every point on that curved standard meter directly to the center of the time sphere. And because the arc is perfectly equidistant from the center, these pseudo-rays all travel the exact same distance.
So they all arrive at the center at the exact same mathematical instant.
Yeah.
At t=0.
Exactly. We've constructed a framework where we can finally say, at this exact moment of observation, this entire unit of measurement arrived at my eye simultaneously.
That's brilliant.
It strips away all the messy physical delays of straight lines in 3D space. And furthermore, remember that this standard meter isn't just sitting stationary. It represents an object moving through the universe.
Right, like the train going past me at 10% the speed of light.
Yes. So if that standard meter is moving at a speed of 0.1 c through the background electromagnetic field, that physical speed is translated into angular velocity.
Okay, angular velocity.
It becomes the speed at which that arc moves along the surface of your time sphere.
I see. So we took a physical straight line, bent it into a curve to standardize the time delay, and then turned its physical speed into rotation along the sphere.
Yes.
It's almost like, okay, imagine a massive stadium of people doing the wave.
Oh, I like this.
Usually you see the wave travel around the stands physically, right? But imagine a stadium wave perfectly timed by a computer. Everyone shouts at the exact precise moment needed so that the sound of every single voice travels through the air and hits a microphone dead center on the field at the exact same millisecond.
That's a perfect way to visualize it.
Yeah.
The physical location of the people in the stands doesn't matter, just like the physical location of the points on the real standard meter doesn't matter.
Right.
The system is designed geometrically so the information arrives simultaneously. By curving the standard meter on the time sphere, the author creates a mathematical stadium wave of light.
I really understand the mechanics now.
Yeah.
It takes the physical object of the standard meter, which usually just represents physical distance, and forces it to perfectly synchronize time. We achieved true simultaneity. But logically, not physically. My eye is still catching chaotic deflection shots, but mathematically, my time sphere organizes it all.
Exactly.
So, okay. What is the ultimate goal here? Why go through all this trouble to create this complex time sphere and bend standard meters?
To build what the author calls a public space, or in the original text, Kikikukan.
A public space. Because right now, we're kind of trapped in our own private spheres.
Exactly. Imagine you are on Earth, standing at the center of your time sphere, and I am an observer on a planet orbiting Sirius, standing at the center of mine.
Okay.
We're light years apart, and we are moving at entirely different speeds and directions through the background electromagnetic field.
Right. And because of information delay and the specific deflection shots required to hit our respective retinas, the light hitting your eye is completely different from the light hitting mine.
Totally different.
We're bathed in different information at different times. We have fundamentally different night skies.
And in a purely physical sense, your reality and my reality are totally out of sync. If we just relied on what our physical retinas were telling us, we could never, ever agree on a universal map.
Because the classic Cartesian grid fails us, it pretends we share the exact same physical instantaneous reality. It pretends we both have the God's eye view.
Precisely.
So how do we agree on a map if our night skies are different? How do the time sphere and the curved standard meter actually help us talk to each other?
Well, the author translates this synchronized time sphere into a complex plane unit circle model.
Okay, we're bringing in complex planes now. Let's break down how that works in this context.
So in mathematics, a complex plane uses real and imaginary numbers to represent rotation and phase, not just flat grid coordinates.
Right.
When we curved the standard meter onto our time sphere, remember we turned physical movement into angular rotation along the surface.
Yes, the angular velocity.
The complex plane unit circle takes that geometry and flattens it into a purely logical mathematical space.
So it maps time delay and angular position instead of flat XYZ coordinates.
Exactly. The messy physical travel of light, the whole dogfight of deflection shooting, is translated into clean, synchronized 2D geometry based entirely on the history of light arrival.
Wow.
It acknowledges that physical simultaneity is impossible, but it creates a supreme, overarching logical framework that is the public space.
So even though my subjective reality on Earth and your subjective reality on Sirius are completely disconnected physically, this mathematical model allows us to synchronize.
Yes.
I map my delayed deflection shot observations onto my time sphere. I use the curved standard meter to ensure mathematical simultaneity, and then I translate my sphere into the complex plane.
And I do the exact same thing on Sirius.
And within that shared mathematical public space, we finally agree on the coordinates of reality.
That's the beauty of it. It achieves the universal synchronization Einstein wanted, but it does it from the ground up. It builds the universe from the physical retina outwards, rather than declaring a floating mathematical grid from the top down.
It honors the physical reality of the observer, the 1.67 meter tall human catching light rays, while still providing a rigorous mathematical structure to map the cosmos.
It forces us to accept a deeply humbling premise, honestly. The universe we see is not the universe that is, but rather the universe that was, specifically tailored to our moving viewpoint.
Let's trace the massive journey we just went on today. Because we started by dismantling Einstein's imaginary floating viewpoints.
Right.
We realized that classic maps of physics are kind of ghost stories because they ignore the brutal physical reality of deflection shooting light rays that have to actively chase down a moving eyeball.
And to fix that fundamentally broken map, we abandoned the flat grid and moved into the time sphere, where distance is entirely dictated by the time it takes light to travel.
And the focal point of that entire model, like the mechanism that actually allows us to measure anything, is the standard meter.
Absolutely central to it all.
We took the physical concept of a straight ruler, projected it into a curved arc on that sphere, and used that geometry to force light from every point on the meter to arrive at the exact same mathematical moment.
Yes.
We basically used a curved ruler to synchronize time, which allowed us to build a shared public space out of entirely different subjective night skies.
The synthesis of physical constraint and mathematical abstraction here is just remarkable. It perfectly resolves the conflict between the delayed reality of the retina and the necessity of a universal map.
After diving into all of this, I feel like you'll truly never look at the night sky or even like a passing car on the highway the exact same way again.
Definitely not.
Every single thing you see is a delayed package of light that had to physically chase you down like a fighter pilot just to be seen. You are the dead center of your own time sphere.
And the author leaves us with a really profound final thought regarding the biology of all this. Yeah, the visual cortex in your brain is constantly performing this complex calculus. Your brain seamlessly handles the deflection shooting, the angular momentum, and the information delay to reconstruct all these chaotic signals into the illusion of a smooth, simultaneous present world.
So it does the math for us in the background, so we don't just trip over our own feet.
Basically, yeah.
But I mean, if your brain is constantly working overtime to invent the now from a barrage of delayed light, what else about your immediate reality is just an incredibly convincing post-processed illusion?
It's a great question. We assume we experience the world directly, unmediated, but we're actually experiencing a highly edited, delayed broadcast stitched together by a biological computer just trying to make sense of a time sphere.
So the next time you're riding that high-speed train and you look down at your shoes, just remember all of the geometric gymnastics that the universe and your brain just perform to show you a ghost, something to ponder.